In this lesson, we're going to learn how we can multiply fractions together. As usual, we're going to need to remember what the different parts of the fractions are. Hopefully you're pretty good at this by now. So for 3/4 here, the numerator is the top and the denominator is the bottom. The numerator is how many pieces we have. The denominator is how many pieces would make up a whole. Hence, that is the 3/4 there. 4 pieces altogether to make up the whole, only 3 of them shaded in. We're also going to do some simplifying in this lesson, and so remember for that we are looking for the highest common factor of the two numbers. In other words, the highest number that goes into 9 and also 12, and that number is 3. There is nothing higher that will go evenly into 9 and 12, and so I will divide them both by 3. And then I end up with 3/4. Remember, I know that something's fully simplified if there is nothing else that will go into my answer. So nothing goes into 3 and 4 except for 1, which we don't bother with. And so I know I've got my fully simplified answer there. We're also going to do some converting between mixed numbers and improper fractions. And so if I've got 3 and 4/5 and I want that to be an improper fraction, I am going to multiply the denominator by the number of wholes, and that tells me how many pieces they've got in total, and I'll just add the extra 4 pieces that I've got on top. So it'll be 3 times 5 plus 4, that's 19, so I end up with 19 over 5. Remember, the denominator is not going to change because that's how many pieces make up a whole, and I haven't changed that. All I've done is add up all the pieces that I've got. Now, with the second one here, we are going to change this into a mixed number. And so from here, what we need to do is we need to say, well, how many times does 3 go into 10? And that'll tell me how many wholes there are. It will also usually give me a remainder, which can make up my fraction part. And so 10 divided by 3 is 3 remainder 1. And so that means it's 3 and 1/3. Remember, this denominator here, once again, doesn't change because I'm not changing how many pieces make up a whole. Okay, let's get into some multiplying here. So we're going to multiply 3/4 times 5/6. Now what will help here is remembering that when you're dealing with fractions, multiply and of tend to mean the same thing. So I can think of this as 3/4 of 5/6. So let's draw 5/6 to start with. And now I'm going to find 3/4 of it. So in other words, I'm going to take 3/4 of each one of these sections here, and so that's what it'll look like. So each section's been cut into 4 now, and I have shaded in just 3 of them. And so the ones I'm interested in are the ones that are double shaded, because I don't need to worry about this one because this bottom one wasn't included in the 5/6, and this one over here, that's not included in the 3/4. And so all these ones in here, they're in the 3/4 of 5/6. So now let's do a little bit of counting. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 shaded ones. And out of a total, if I count all of those, I believe it'll be a total of 24. So that means I know that 3/4 of 5/6, or 3/4 times 5/6, is equal to 15 over 24. And notice what's really happened here is I've got 5 of these here, and each one has now got 3 shaded sections that I want. So that means it's 5 lots of 3. In other words, I've just multiplied these numerators together. That's ended up what happening. Just multiplied them together. And I started off with 6 sections altogether, and each of those 6 got split into another 4. And so that means I've got 6 lots of 4, which is just the same as multiplying those denominators. And so we can multiply the numerators together, and we can multiply the denominators together to get our answer. Now note, first of all, I did not need a lowest common denominator. If you find the lowest common denominator, you still might end up with the right answer in the end, but you're going to make it so much harder and you're wasting your time. You don't need it when multiplying, only when adding or subtracting. It doesn't matter. It didn't matter here that the pieces weren't the same size. It had nothing to do with what we were doing. So what we're going to do is we are, however, going to simplify this answer here. And so 15 over 24, something goes into 15 and 24, and that's 3. So let's divide both of those by 3, and we end up with 5 over 8. And that's fine. That's actually my final answer, and it's correct. But what if these numbers are really big? what if I asked you to multiply 32 by 18? That's going to take you a long time to work out. And then after you've done that and you end up with an answer that's in the hundreds, you've got to work out what goes into those two numbers, and suddenly it all gets very complicated. Well, fortunately, there's something that can solve both problems at once for us, and that is we can simplify this before we times it. The beauty of multiplying fractions is that you can simplify before you even multiply them together. And here's how it works. So I'll just write that down here. And here's how it works. What you do is you look for any numerator and any denominator. Like this one here, the numerator and the denominator are the same fraction. When you're multiplying, it doesn't have to be though. And so I can take this 3 and this 6, and I can simplify them as if they were in the same fraction. And so what goes into 3 and goes into 6? It's 3. Just like it did up there, coincidentally. And so how many times does 3 go into 3? That's only once. You just cross it out and you write the new number once you've done the division. And how many times does 3 go into 6? It's 2. So cross it out and write the new number. Now look what happens when I multiply. 1 by 5 is 5. 4 by 2 is 8. So I've done two great things there. The first one is I went straight to my right answer. I didn't have to simplify. And the second one is I made these numbers smaller before I multiplied them, which means multiplying them is easier. So this is a really important process you want to get really good at because it makes the questions easier to answer. Let's take a bit of a closer look at that simplifying. So I can pick any numerator and any denominator to simplify. And so there's no order that you need to do it in. Just pick any numerator and any denominator, anything you can see here. All you can't do is pick two denominators or two numerators. And so I'm going to pick this 10 and this 35 because I've noticed 5 goes into both of those. You might have seen some other options, and that's okay. And so I'm going to say 5 goes into 10 twice, so cross out the 10 and put a 2 there. And 5 goes into 35 7 times, and so we cross out the 35 and we put a 7 there. So now I've got a 2 on top of this fraction and a 7 on the bottom of this one. The 10 and 35, they're gone, that you can't use them ever again. And so anything else I can simplify. Well, see this 5 and this 15? 5 goes into 5 once and 15 3 times. So let's cross those out and put their simplified numbers there. And now when I do the multiplication, 2 times 1 is 2, 3 times 7 is 21. Notice I started with 15 times 35. That's pretty hard to work out. But 3 times 7, that's easy to work out. It's on our times tables. And our answer is already simplified. So it's a really important process. I want to take just one more look at this question here. I want to try simplifying it a different way. This time what I'm going to do is I'm going to say, well, 5 goes into 10 twice and 15 3 times. Remember the last time I used 10 and 35. This time I'm going to use 10 and 15 instead and see what happens. So it goes into 10 twice and it goes into 15 3 times. Now I'm going to go 5 and 35. 5 goes into 5 once and it goes into 35 7 times. And that means 2 times 1 is 2, 3 times 7 is 21. Notice I've got exactly the same answer. So here's the key point. It doesn't matter which numerator and which denominator you're simplifying or what order you do it in. You'll end up with exactly the same answer anyway, so don't worry about it. I would note in these examples here, I've always simplified using 5. You don't have to though. I could have simplified using 5 the first time, and if it worked I could use any other number the second time. And if I was simplifying a third time, I could use another number again. So don't think you have to use the same number every time just because that's what I did in here. You'll see that a bit more in the examples. Now just one or two more things about simplifying, and the first thing is that we can use changed numbers again. So what I mean by that is if we simplify this one, 12 and 16, 4 goes into 12 and 16, it goes into 12 3 times, and it goes into 16 4 times. Notice that there's a 4 on the top and a 4 on the bottom. Well, 4 goes into 4 once, and it goes into 4 once. In fact, anytime there's a number on the top and the bottom the same, that's a really easy thing. You should do that straight away because you cross them both out and it makes 1. Notice that I crossed out the 4 here. That's because that's just the new number that's on the bottom of the fraction. I can't use the 16 again, but I can use the new number again. And so that's fine. And I could use the 3 again if I wanted to. And so what I'm going to do now, I'm going to do my multiplying. And if you just notice something that you think I haven't, just give me a moment. So let's do 3 times 1 is 3. 9 times 1 is 9, and I get 3 over 9. And suddenly I realize, hang on, 3 goes into 3, and it also goes into 9. Now what happened is before, I didn't simplify these. I could have, but I didn't. But that's okay. I'm not going to get the wrong answer. I just haven't got the right answer yet, because you can always still simplify the answer if necessary. So whenever you do this, always have a look at your final answer, and if you can simplify it, you still do that. So 3 goes into 3 and 9, so divide them both by 3, and you'd end up with 1 over 3. So I get there in the end. Now, if I did simplify these properly, and I crossed out the 3 and put a 1, crossed out the 9 and put a 3, I would have ended up straight at that answer. So that's actually better. But I still got there in the end. Now, I know this is a bit of a longer one, but we are getting there. Another thing to point out is that if you've got an of, that's typically the same as times, as we mentioned before. And so this will become 3/4 times. And this 7 here, I'd like that to be a fraction, because I just learned how to multiply fractions. That's okay. Every whole number can become a fraction just by putting it over 1, like that. So 3/4 of 7 is the same as 3/4 times 7 over 1. And so of, change to multiply, whole numbers, just put a 1 underneath, and now it's a fraction. Finally, if you've got mixed numbers, there's no choice when you're multiplying. You must convert them to improper fractions. Never try and multiply mixed numbers. And so if I had this as my question on the next line down, I'd simply convert each one of them to an improper fraction first, and then I could try and multiply them together, doing all my normal simplifying and everything. Right, let's go through some examples just to make sure we're definitely right. So we've got 5 12s times 8 15ths. Let's write that down to start with. And now let's see, is there anything I can simplify? 5 goes into 5 once and into 15 3 times. So let's cross that out and put the new numbers. Now remember, I can't do 12 and 3, even though 3 goes into 12, not because 3 is a change number, but because they're both on the bottom. One must be a numerator, the other one must be a denominator. But I can do 8 and 12. 8 may not go into 12, but 4 does go into both of them. So 4 goes into 12 3 times, and it goes into 8 twice. And now I can't see anything else that I can simplify, so I just do my multiplication, 1 by 2 and 3 by 3, and I get straight to my final answer there. And it can just go next to it because I'm going straight to my final answer. In the next one, I'm going to find 4/5 of 20. So when I write it down, I'm not going to write of, I'm going to write a times sign, and with 20, I'm going to put it straight over 1. So like that. And now I'm going to multiply it just like two normal fractions. Does anything 5 and 20 works? And so I can go 5 goes into 5 once and into 24 times. So let's fix that up. And now I've got 4 times 4 on top, 1 times 1 on the bottom. That means I get 16 over 1. And now we're going to do the opposite of what we did here. When I put the 20 over 1, I'm going to realize 16 over 1, that's just the same as 16. And so you should do that extra step there. Don't ever leave an answer over 1, because we know it's just the same as a whole number then. And notice I went downwards then because I've already got an equal sign there, so I don't want another one next to it. So I went down and just put my answer underneath. And now let's take a look at when we're multiplying mixed numbers. Let's write the question down. Before I do anything else, I'm going to get rid of those mixed numbers. I hate them. I can't multiply with them. So 2 times 2 plus 1 is 5, and 1 times 3 plus 1 is 4. So I get my improper fractions there. And now I can do any simplifying as normal. And so nothing goes into 5 and 3 or 4 and 3 or 5 and 2, but something does go into 2 and 4. And so I can cross out the 2. 2 goes into 2 once and it goes into 4 twice. Now I can do my multiplication. 5 times 2 is 10. 1 times 3 is 3. Notice I'm going downwards here because the first thing I had to do was change these into improper fractions. And so because I'm not going straight to my final answer, I'm going down the page. And now finally, this is an improper fraction here, what I've ended up with. We'll just pop that back into a mixed number. So 3 goes into 10 3 times with 1 remainder. So that gets me my mixed number answer of 3 1/3. Right, after all that, let's try some practice questions. Remember to pause the video. And there are the solutions to that with all the working that should be shown. You should, of course, be showing all the simplifying that you're doing. So in the first one, I wrote down the question and I looked for things to simplify. The 5 and the 10 could be simplified. 5 goes into 5 once, goes into 10 twice, and the 3 and the 9 was also simplified because 3 goes into 3 once, and it goes into 9 3 times. So my new fractions were 1 over 3 and 1 over 2. I multiplied my numerators, got 1, multiplied my denominators and got 6, and that was my answer. In practice question, the second one, I wrote out the question, but as I did so, I changed the of into a times, and I just put a 1 under the 12, so it became a fraction. And then I noticed that 3 goes into 3 once, and into 12 4 times, so I did that simplifying. I couldn't use the 4 and the 2 because they're both numerators, and so I had no choice. I just had to do my multiplication. So 2 times 4 is 8. 1 times 1 is 1. I realized I'm not going to finish the answer with a 1 on the bottom, and so I just changed it into 8, back into a whole number. Now the last one, it all worked pretty much the same except I had mixed numbers, and so I wrote down the question as it was, and I changed the mixed numbers into improper fractions. And I looked and suddenly I realized, hey, I can't actually simplify it all here. Nothing goes into 9 and 5 or 7 and 2 or anything there, so I'll just go straight to multiplying. 7 times 9 is 63, 5 times 2 is 10, and then I just changed that into a mixed number by saying how many times does 10 go into 63, and it was 6 with 3 remainder. Here's some extra practice questions. If you need to have another go, remember to pause the video. And there's our solutions with those, with the working that you should be showing. And that brings us to the end of the lesson.